we've looked at the basic idea of integration, and then we've looked at the ones that just come off the formula sheet. There's a couple of other ones on the formula sheet which are kind of like special cases. Integration just happens to be questions. So if I asked you to integrate x squared times, let's make it 3x squared times x cubed dx. Okay. We're going to do this in two different ways and show you what's going on. The first thing you've got to realize is that for integration, we do not have a product, quotient, and chain rule. So no product, quotient, chain. Okay? Definitely worth remembering, or not trying to do it, because there is no actual. When you go on to the next level, there's a thing called integration by parts, which sort of does a bit of producty, but at this stage, let's not worry about that. So effectively, we don't have a product, a quotient, or a chain rule. So when you look at this one, it's not, you can't do it as a product. So you've got to find some other way of doing it. And there's two ways of doing it. One is you can do a bit of algebra before you start, and you can turn it into just a simple thing. So that's exactly the same as the integral of 3x to the power of 5. Okay, just x cubed times x squared is x to the power of 5. So you're allowed to do legitimate algebra before you integrate. You can tidy it up. And then now I can integrate that. So that's 3. And if I'm integrating x to the power of 5, I add 1 and divide by the new power. So that's going to be x to the power of 6 divided by 6. So that's a half x to the power of 6 plus c. Okay, so that's one way of doing it. And that works nicely. And in this case, that was good because it's a very simple multiplication. You can do it nice and easily, but it won't always be the case. The other way of doing it is on your formula sheet, you will have noticed that there is, right down the bottom of the formula sheet, there's a case where it says g dash of x, g of x, and it tells us the answer is a half g of x squared plus k. Okay. So if it just happens, if you get lucky and get a question that just happens to be two things multiplied together, where one is the derivative of the other one, then this is the answer. So just got lucky and had the two things where one happens to be the derivative of the other. And that's exactly what the case is here, isn't it? If I differentiate x cubed, I get 3x squared. So it just happens, I just got lucky, that this one just happens to be the derivative of that one. Yep. And it tells us over here that the answer to that is a half of the one that hasn't been differentiated, so in this case the g, so x cubed all squared. So it's a half of x cubed squared. And x cubed squared is just multiply the things, x to the power of 6. They're both the same, yo, so it works either way. So doing the multiplication and doing normal integration, or following this, man, I got lucky, and it just happens to be the derivative of the other one, we can use that formula and do it that way as well. Okay, so that gives us the ability to deal with things that look like that, where one just happens to be the derivative of the other one. And there's a similar thing on your formula sheet for a division one. So if you happen to find the top line just happens to be the derivative of the bottom line, then the answer is the natural log, or log to the base e, of the bottom one, plus your constant. Yep. So you've got those two special cases where it just happens to be, and you can have a look into. So if you see something you think looks like it's going to be a product, and you think, oh, I haven't got a product rule for integration, what am I going to do? Check out to see whether it happens to fall into that category. Or if you see one that looks like it's going to be a quotient, and you haven't got a quotient rule, check out and see if it just happens that the top one is the derivative of the bottom one. And if it is, then you can use this rule and make it work. Okay, so that's just comes up quite a lot. Sometimes you can manipulate these things a little bit to make them look like that, even though they're not exactly of that type. Let's very quickly have a look and see if we can do one. We can have a look at it like that. Let's see if I can make one up. So we happen to have something that looked like the integral of 5x squared plus 6x, and on the top we're going to have 20x plus 12 dx. Okay, so this is one where I first look at that and I go, I haven't got a quotient rule, I can't do that division easily, what am I going to do? I feel like I'm stuffed. There's not much I can do. And I ask myself the question, is it one of these ones? Does the top just happen to be the derivative of the bottom? And I look at that and I go, well, the derivative of the bottom is 10x plus 6, which isn't the top. But what say I did this? If I left the bottom like it is, and I put 10x plus 6 on here, now I have got the top as the derivative of the bottom, but that's not the same as that. I've changed it. What have I done? I've halved the top line, but if I put a 2 out the front of the whole thing, then if I put this 2 back in, I'd get 20x plus 12. So I'd get the same. So these two things are still exactly the same. I haven't done anything naughty, I haven't changed anything, as long as, and you are, allowed to bring a constant out the front. As long as there's a multiplying thing, you can bring it out the front of the whole thing. And now I've got the 2, and then I do the integration. And I happen to be lucky that the top just happens to be the derivative of the bottom. So in that case, I can use this rule. The top just happens to be the derivative of the bottom. So the answer is the natural log of the bottom. So natural log of the bottom. And that's all there is to it. Okay, so sometimes with a little bit of a jiggle, you can make them look like one of these two scenarios. And once you're in that scenario, then you can just use the formula, and away you go, and you get the answer like that. So a little bit of a cheat. Not cheating, it's good creative maths, that's what you should be doing. But it does mean that things that aren't quite like this, you can still use these two special cases. So they're not quite as just happens to be as you might think. Okay, so just remembering, the formula sheet has these two extra ones on it, which sort of give you some products and quotients, not a universal product and quotient rule, but enough to be able to address a variety of integrations that look producty and quotienty. Okay, integration that just happens to be.